Today is all about learning and prototyping. I have finished the shader class for the terrain and I have started to explore the Vertex Shader source code. And yep, I've used AI to help me understand everything, every single part of the code, every single little detail. And it's literally a life changer. It's so good to be alive right now, to be honest. Oh, sorry. Because it makes things much more convenient. And yeah, it helps me learn a lot. It helps me get those questions, those like things that I want to know that I don't understand. It helps me. It's like having a teacher, bro, in front of you, 24/7, no pay. It's crazy. Anyways, today is day 31 of documenting my journey of creating SpaceWise. Like, I'm going from scratch, from knowing absolutely nothing, to creating this app, to studying the math, to studying the programming, to studying the computer graphics, to studying everything and trying to create stuff. And I'm recording my struggles and everything, my methods. So yeah, so I can look back one day, see this, and be grateful, man. Be so grateful that I did this, because yeah, really nice. It's really nice. So yeah, I'm gonna start with the time lapse of me working in the morning. Right now I'm recording this at night because in the morning I wake up and I have no energy. I literally look depressed. So yeah, let's get started. Hey, alright. Well, let me just see. Ooh, like this. I have just finished studying. Ooh, oh my goodness, my bad. I have just finished studying code, and I have also just created a repository for to work on my laptop at school as well, and to play around with the code. But I won't go into too much detail right now because I have no time. I have to shower, meditate, cook, and get to school. Yeah. So that's basically it. Yeah, what I've been doing is, let me see, what have I done? I have finished the shader.cpp file. So today I started over here. I kind of went a bit over this, read it, and like internalized what this does, and went to AI, to Perplexity more specifically, and not asked because I had asked the day before, but read the conversation and tried to understand this. Then I started. Okay, I'm not gonna do it anymore, but I just got the code from here. I got this code, and I really or here, and I really tried to understand it, and I asked for it. I asked over here to explain it to me, every little part of the code. I tried to understand it, tried to like put this in my own words. I tried to really see what's going on. If I had any questions, any doubts, if I wanted to know something, I just asked. Like, this is so crazy, bro, that you have a personal teacher 24/7. This is just nuts. Like, it's crazy. It's so good. I feel amazing because of this, bro. It's a great time to be alive, to be honest. And yeah, I just asked, then I created these steps to like have a big picture view of how do you compile the shaders, how do you create the shader program. And yeah, I've just been going through the code and trying to understand it, putting comments. By the way, these are not comments that I would usually put on a program. These are like understanding comments. This is an understanding prototype, right? I'm not like, look, there's an example even here. I'm not like, this is too cluttered for an actual program that's gonna be launched. So this is just for me to understand. I'm also thinking about trying to test myself on what happens here, on what happens to the with the code, because I'm obviously gonna forget about this in a day or two. So I need to like have a way to keep the information in my mind, or at least the general understanding of it, right, of this program. So I'm thinking of testing myself, I don't know, 20 minutes some days on the shader CPP, on the shader class, for example. And I will create some questions to test myself today, or if I can today, well, next day, no problem. And then I will test myself on those questions and try to answer them. If I can't answer them and it's too hard, then I will have a dedicated like small 10-minute study session, because I don't want this to take a lot of time, because I don't have much time to actually learn new things and work on them. So if I have to like spend most of my time just relearning everything, one, I'm not using a very good study technique then, but two, like, then I'm not making progress, because I don't have that much time. I have school like always, and gym and stuff like that. Yeah, that's basically what I have done, and right now I'm in the process of creating the shaders over here on Visual Studio Code, because on Visual Studio Community you cannot do that, you cannot see this file. I don't know why, but I don't know. Yeah, but I'm right now trying to create this, and I'm doing the same thing, just commenting, trying to understand things. Here I have many questions, like many, as you can see over here. Like, these are my questions and my doubts, the things that I want to really understand right now. And yeah, I'm on my way to do this. I haven't started the fragment shader yet, but I will do the vertex shader, the fragment shader. Then I will do this, which is like almost nothing, just implementing the class on the program. And I will try to see what happens. If it works, amazing, we can keep going and move on. I don't know what I will do, but we can move on. If it doesn't work, then I can think and ask and try to understand why it doesn't work. And that's really what I'm looking for, trying to understand the code, why it doesn't work, why it works. That's really what I'm looking for. So yeah, I'm gonna get ready and I'll see you in a second. Alright, it's now the end of the day. I have went to school in the morning, I have eaten, I have went to school in the afternoon, and now I'm back. Yeah, right now I'm gonna get eating and I'm gonna eat a bunch, because I didn't have breakfast, like, at all. I usually just have a little bit of peanuts to get the calories in before I go to school, but not today. I have some chicken breast over here. I have some cheese that I've been eating while I've been cooking. We have here some 99% dark chocolate. Oh, 99%. Here we got some peanuts. Let's get it done. Alright, summary section of the video. So here I'm gonna be just saying and trying to explain a bit more in depth what have I done today, what I have done today. So yeah, yesterday or the other day I stopped here on this block, and under is everything that I've done plus something else. So yeah, today I read this a little bit, and I went to AI to check the questions and the answers that I had asked the previous day, and try to like understand this code and the purpose of it. So if I think I can show it to you over here. I don't know where this would be, to be honest. I don't know, but either way, yeah, I asked some questions and I got my answers. Then I went here. Oh yes sir. So as you see, I have finished there. This is the piece of code, and what I'm doing right now is just getting a piece of code. If I don't understand it, I ask on a different like chat, I guess, and I ask what it does. If I don't understand it, I ask it to go more in depth and to get it to explain it to me more clearly. And yeah, I just then put notes over here, and of course this is very cluttered. This is not gonna go to production. This is just a program, a learning program, kind of learning program. So I actually know what the code is doing because I'm actually studying this. I don't really know much, but it's so good when things just start clicking. The feeling is amazing. Yeah, so I started with this. How do we compile shaders, and then how do we create a shader program which is then used by OpenGL. So here we have these steps, kind of like the big picture view, which is like prepare the shader code, create an empty shader, then assign the source code of the shader to the actual shader objects, and then we compile the shaders using this function. So yeah, let me just show you the code of the shaders. Actually, I don't have it here. I have it right under. Here it is. So this would be the code that we are going to attach. What is this? So yeah, this is the code that we are trying to attach, and to the program. Then here we create individual Here we create individual pointers to the shader code. So yeah, very self-explanatory. Then we create the shader objects, the empty objects, and then we assign the shader source code to the object, which means we attach it. We assign the source code. How do you assign it? With this function. So I just put here the parameters and saying what it is, the vertex ID, indicating that it's only one string, like one string being passed as the source code. The source code is just one big string. It's not like lines, it's just a string. And yeah, this is the pointer to the code, and indicating that it's null terminated, which means that like OpenGL doesn't have to put a specific length. When it reads the code and it reaches a null, it just stops, which is very good for performance. Next, here we compile them with this function, and here this is a user-defined function, which is a function that we create, and it just checks for errors. Then we got a fragment shader, which is like the same as the vertex. I mean, not the same, but it's the same process, right? Where is the vertex shader, bro? Here. Yeah, it's the same process. Then we create the shader program, which is kind of like joining all the programs, all the shaders, joining all the shaders and basically they can be called at the same time with one OpenGL call, draw call. Like when you call to draw something, well, with one call you call every shader. I don't know if I explained it correctly, but it sounds like this. Here the steps are creating an empty program, kind of like with the shaders. Then we attached the previously compiled shaders, which means like which we have compiled over here to the program. Yeah, we attach them to the program, and then we link the shaders. Here, as we said, we created it, returns an ID, then we attach the shaders, and then we combine them into a single, we link them, we combine them into a single executable raw file that will run on the GPU. Yeah, here we compile errors on, here we check for compile errors on the program, and then we delete the shaders, because after compiling them we do not need them. I mean, after linking them we do not need them anymore, because the program creates a copy of the shaders, so we just delete them, and that's good for like freeing resources and memory. And yeah, how as it says here, we do not longer need the shaders. Here's a method for using the actual shader, and yeah, here it is. And then this is something that was really impactful for me, and I found really interesting this morning. So these are like functions to create uniforms. What are uniforms? They're like shader variables, or at least I see them that way. And they're variables, global variables that are accessible by all shaders. Yeah, by all shader stages. So we have like Vertex Shader, the Fragment Shader, the Geometry Shader. They are accessible everywhere. And the way I see it is we have a CPU world, which is like the code, and then we have the GPU world, which is like the shaders. And they can't really like talk to each other. Like they're on separate sections, and they cannot talk to each other. And these functions create uniforms. Uniform variables are the ones that allow the connection between the CPU and the GPU. And like, how do they do this? So, well, they allow you to change things like lightning, bro, I can't speak, it's crazy, colors, or like transformation matrices, which, to be honest, I don't really know what those are yet. Having a real hard time, bro, to talk right now. I don't know why. No problem. Let me just clear my thoughts here. So yeah, they allow you to change things in real time without having to recompile the shaders again. And here I have an example. So I can actually set this variable of ambient strength that is could be on a shader, and I can just change the value with the code instead of having to, like in real time, instead of having to recompile the shader. It's very good. This also allows you to set a value once, like it sets this once, and you can use it on multiple shaders. Yeah, here we can change the texture unit, the projection matrix. We can change all of this in the code, which is very nice. And yeah, this method is for integer values, for float parameters, yeah. And here we set a matrix, 4x4 matrix. Here the method gets the uniform location on the shader. The uniform is basically the uniform variable. Maybe it could be like ambient strength, it could be texture 1, it could be projection. That's the name of the variable, that's the uniform. Then we have the shader program ID, and here we have parameters, which are explained over here. And then we have the function check compile errors, which is the one that I've spoken about. What else? Yeah, I've tried to understand everything here. And then the next step was to start actually trying to understand the source code of the shader. And here I have put some comments. So this shader transforms each vertex from model space to clip space and passes texture coordinates to the fragment shader. How? With this, the out keyword. And here it assigns the value of the texture code, the net, that will go to the fragment shader, to the texture coordinate that's right now here. And I don't really understand what is model space to clip space. I kind of have an idea, but I don't really like have an understanding of it. I know that clip space, it's like screen coordinates that go from -1 to 1 on the x and y axis. So like the maximum coordinate you can have is 1 or -1. Kind of like, this reminds me of like in trigonometry the metric circle. I think that's how you call it. But yeah, that's basically what I have done today. And to do the next day would be to go to the prompt and answer the questions, because I had a bunch of questions that I wanted to get answered. Let me see if I can show it to you. Show them. Yeah, here they are. So I had many doubts and things that I wanted to know. So the next day I'm gonna read this and study this and ask more questions, actually try to understand. Boom, done. I think this has been a bit long. 13 minutes. Damn. I hope I have explained this at least a little bit right. I'm not any expert. Like, I'm learning this. I have only learned this today, so I probably haven't explained it really well. I haven't explained it, I don't know, the best way that I could. But this is life. Life is life. So anyway, this is very long right now, so I'm gonna get going. I'm gonna end the video. So wish you a good one. Bye bye.